Welcome back to Elementary Statistics. We are in part 15 today. We are going to be looking at the variable types, specifically with numbers here. And first of all, when we look at this, the main reason why I want to go over this, so I'm going to start backwards on the slide, is when we know the type of data that we have, that will often determine how we want to portray those data. For instance, we might use a heat map for some data. We might use a scatter plot for some data. And we might use something like a pie chart for some data, right? So the type of data can sometimes determine that. Not always. We may use multiple different types of portrayals of this, but this can often be a good place to start. For instance, categorical, when you have a few categories. It's very popular, by the way, with like, ETFs. When they have a couple of different sectors they focus on, they usually put that in a pie chart. Though it is kind of interesting. You could do that with... they also use heat maps too, but you could do that with other ways of portraying that data as well. Especially if it's like, let's say, commodities, you could do that across, let's say, a periodic table. Okay, so the first two basic types of variables that we're going to be talking about are categorical and quantitative. So the categorical data, variable types, are just data that belong to a specific set. So if you think about this, this would be like these almost like your yes and no data. Can you do pull-ups? Yes or no, right? That's a category. There's the people that can and the people that can't. And by the way, numerical data can also be converted, quantitative data, I should say, can be converted to categorical. Case in point, although blood pressure is quantitative, it's numerical, right? We can convert good or high. We can say medium blood pressure. We can say low. We could even do it like very high, moderate, low, and very low, right? We could distribute it across categories. So keep in mind that we can convert any quantitative set to categorical when we think about it. And that may be very useful in statistics, by the way. If we're looking at data, we may say, hey, let's convert this to a yes or no, or let's convert this to a kind of 1 to 5 scale, or 1 to 10, or 1 to 7 scale, and see what we get. That can actually be very useful in many techniques. In the case of quantitative, it is, of course, numerical categories or sets. So the examples here are, of course, like things like annual income categories, age, etc. Those are numerical, right? Oh yeah, I forgot to say, on the categorical, another example is like rent, own, live with relatives, etc., right? In the case of quantitative data we have here, quantitative variables, we have two different types. We have, of course, discrete, which are whole numerical values. At this current time, it's not possible to have a half a child or a third of a child. You have a number of children, which is 0, 1, 2, 3, 4, etc., right? And then, of course, we have continuous numerical values. These are numerical values with intervals, so it could be something like height. Like if you're 6 foot, 2.5 inches, right? You can be 0.5 inches. You can be 0.34 inches. You could be 0.75 inches, right? So it may not be a whole number. You cannot have 0.5 kids right now. And so this will help us determine how do we want to plot the data, right? So as a case in point, when it comes to, let's go to the quantitative. In fact, we looked at an example. I can find it really fast. One of the heat maps, just as a case in point that we've already looked at here. You can see this is one of the newer. This wasn't around when I was a kid. So when I first learned statistics, this was not available. We could not do heat maps like this, which really, I mean, it changes the way you look at data. This is what's so great about math, at least in my opinion now, is that when we look at data now, we can really come to conclusions very quickly. We can determine things very quickly because we can visualize it. And this is a great example. We can see all the rich areas in the United States. We can see kind of the cost of living, and we can adjust for that. And it starts to make sense. When we look at something like this, it quickly answers questions. Whereas if we were to try to imagine putting counties on like a pie chart or a scatter plot or a bar graph and trying to compare all these different counties, I mean, it would be exhausting to do. But you put it on a heat map, and then you can see things more accurately, and you're like, okay, well, this is where the high incomes are, this is where the high wealth are. Okay, now let's cross that over with another heat map that looks at the cost of living, and then let's cross that over another heat map that looks at, the profession type, etc. And suddenly you get a completely different look at the data. So this is a great example of how, depending on the data that we're looking at, depending on the type of data and the type of variables we're looking at, that will probably help us determine how we want to portray that data for others.